Hi, and welcome to another instructional video for CSCI 1300. In this video, we will cover the use of characters as a data type and how they relate to strings, and also how the ASCII table relates to both strings and characters in your computer. We will also briefly cover how to do typecasting and how to do input-output operations with chars. So the first thing I want to go over is we've dealt with strings before. So if we declare a string, we would have to declare a string and give it a variable name, and then give it some characters within quotation marks. Quotation marks define a string as compared to a character, and strings work very similar, except they use single quotation marks, but have a similar kind of syntax. So in order to declare a character, we have to use the char data type. Say we wanted to declare an A by itself, we could set it in single quotations equal to itself. Or we could also say that A is also equal to its ASCII value. Well, its ASCII value, if we look at the ASCII value, let's look at the ASCII chart for a sec. And the ASCII chart is something that you can look up and learn more about yourself on the internet. But basically, everything in your computer that has a symbolic value also contains a decimal value as well to represent it in the computer. So for instance, if we look at the lowercase alphabet, the lowercase a starts at 97 with a decimal value of 97 and goes all the way to Z, which has a decimal value of 122. So if we wanted to actually denote A with its decimal value, we could set it with the decimal value of 97. I'll get into doing that here in a sec when we go into typecasting. So say we set B equal to itself and C, well, let's set C equal to something using the ASCII table. So if every one of these characters has a decimal number associated with it, we can say that A is 97 and B is 98 and C is 99. So what I'm going to say is that C as a character is the letter A plus 2 in its decimal value. So we're going to say that char C is equal to 97 plus 2, which equals 99, which should print a C to the screen. So let's test that out. And you can see here that when we're printing characters, we can print them to the screen just like strings by concatenating them together through a chain of print statements or a print statement. And let's save and see what we get from the terminal. So we've printed "You have to know your ABCs." We gathered an A, B, and C and stored them directly. The C was stored from taking A and changing its decimal value to a C. So we can manipulate the characters in this way very flexibly. If you're looking to add or subtract and change your character representation, you can do so in a decimal or numerical format by doing so. If we wanted to input characters, we could also do that as well. So we could say something like input 3 characters in a row, and then we'll have to declare char in. Let's say this is A1, and we'll declare B1 and C1. And now what we'll do is we will cin A sub 1, B sub 1, and C sub 1. We will then print the same thing to the screen using our new variables. And instead of A, we're going to use A sub 1, B sub 1, C sub 1. So let's test that now. And you can see that we got the same thing. We input 3 characters in a row, and we were able to store them into A sub 1, B sub 1, and C sub 1, and print the exact same results back to the user. So let's see here. Let's talk about typecasting now that we have gone over input and output operations. So typecasting is modifying a data type, a variable of a data type, to a variable of a data type that you wish to use, that is needed. So how do we do that? Well, say we have a num, say it's 42. We could create a character called n by taking the variable num and adding parentheses in front of it with the word char to denote that we want to change num, whatever is stored in num, numerically into a character. So it's almost like taking some value and turning it into a symbolic representation. So we're taking the decimal or numerical value that is listed in the variable num, which is 42, and saying that we want it to be represented now in a new variable called n, which will be the symbolic representation of 42 in the ASCII table. Similarly, we could do the same thing with another variable, and say we take just a number like 56. We can typecast 56 as well, and it will represent the ASCII symbolic value on your keyboard for 56 in the ASCII table. And if we are to print this, let's say that this is num is, let's say that this is num1 is, and we will print n, the variable n, and then we will print num2 is, and we'll print n sub 2. And we're going to see what we get from the terminal. And we're going to check this against the ASCII table to see what we get as well. So let's see what we get from the compilation. Oh, this is interesting. So notice that num1 is represented by an asterisk or a star, and num2 is coming back as another number. It's coming back as 8. So let's check. If we know that num1 is 42, so let's check that. We know that num2 is 56. 42 here in the ASCII table is represented by the symbol of the asterisk. So that's actually true. We are able to print based on the decimal or numerical value of the symbol. And if we look at 56, well, this is really interesting because the decimal value of 56 actually represents the symbolic value of the number 8. So the character 8 is actually represented with a decimal value of 56, which is some weird stuff, but it's actually true. And with that, I think I've covered pretty much everything that you need to know for the moment on chars. We've covered how to declare chars, how to manipulate them using the ASCII table of values, how to perform input operations in multiple ways, and also how to do typecasting. Thanks again for watching, and happy coding!